a little bit on slope field. All right, so this is question from 2010, Form B, number 5. So consider the differential equation that's given right over here. And then on the axis provided, sketch a slope field for the given differential equation on these 12 points indicated. And then sketch the solution if it passes through here. Alrighty, so then let's try to look at this one first. So I realized that when is this one equal to 0? Oh, that's when x equals -1. So when x equals -1, no matter what, the graph will always be, the slope will be always be equal to 0. So here I have, let me just try to use the red one. 0 here, 0 here, and then 0 here, 0 here. Because when y is equal to 0, it doesn't exist. That's why. Alrighty, so let's continue. Then all the other points, actually, we just have to plug in the values and then see what happens. Here, this one is x equal to 0, y equals 1. So 0 and then 1, then it's equal to 1. Slope is 1, so it's like a 45-degree angle. How about a 0, 2? So when this one is a 0, 2, and then it becomes 1/2. So it kind of flattens out a little bit. How about here? When x equals 1, and then y equals 1. So it becomes 2. Slope is 2, so it's a little bit steeper. Maybe let me try. Okay. And then how about here? 1, 2. So when x equals 1, y equals 2, then it becomes 1. Slope is 1, so same thing as this one. How about here? When slope is equal to, when x equals 0, y equals -1, then slope is -1. So here we get -45. I think this one is -45. Here, x equal to 0, y equals -2, then slope is -1/2. So it becomes flattens out a little bit. And here it becomes -2. Something like that. But we realize that given point is 0, -1. So 0, this is a given point. Then what's going to be happening? They want to sketch the solution. So it's going to go straight down this way, riding along. And then here. But x cannot be, y cannot be equal to 0. So I'm going to just put an open circle right over here. How about that? So that's what we can do for part A. Let's look at part B. While the slope field in part A is drawn only at 12 points, it is defined for every point in the xy plane where y is not equal to 0. Describe all points in the plane where slope is equal to -1. So what does that mean? Slope has to be equal to -1. So that means part B, I'm going to say -1 is equal to x plus y, on x plus 1 rather, over y. Then you get to realize that y will be equal to x plus 1 over -1, which becomes y equals -x minus 1. So that means those are the values. So here we get describe all points. So that means it has to satisfy this condition and y cannot be equal to 0. So all the points that satisfy these two conditions will be my answer. Alrighty, let's look at part C. Find particular solution with this given condition. So what I'm going to do is I'm going to separate the variables. So here we get y dy and then x plus 1 dx. So when I integrate this one, I get y squared over 2 is equal to x squared over 2 plus x plus c. So I can multiply everything by 2. Then we get to realize that y squared is equal to x squared plus 2x plus c. So I'm going to plug in 0 and then -2. So when I plug in -2 in place of y, so we get -2 squared equal to 0 squared plus 2 times 0 plus c. Then you get to realize that c must be equal to 4. Then what is our answer? Y squared should be equal to x squared plus 2x plus 4. But the thing is, in order for you to solve for y by itself, because that's what they want you to do, I'm going to go down here, y will be equal to plus or minus square root of x squared plus 2x plus 4. But wait a minute. Remember how y was defined for the negative value? So I'm going to just keep this one as negative. So y must be equal to negative radical x squared plus 2x plus 4. So that becomes our answer. Alrighty, let's move on to the next question. Number 5. Consider the differential equation here, and they want you to sketch the slope field. Alright, so let's try to look at that. And in this case, what I'm going to do is, when is this one equal to 0? Oh, I realize that this one is equal to 0 when y is equal to 1. So when y is equal to 1, I'm going to write down the horizontal line segment. That's first. And when x equal to 0, I don't have anything. And then how about the other values? All right. So how about here? X equals negative 1. But in fact, whether it's negative 1 or positive 1 is the same, because x has been squared. So whatever I'm doing here will be the same thing that I'll be doing here. Y is equal to 0. So then y is equal to 0, so we get negative 1 over 1. So we get negative 1. Same thing here, negative 1. How about here? When y is equal to 2, so 2 minus 1, which becomes positive 1 over 1, so we get positive 1 here, 45 degrees. How about here? When x equals 2, so then negative 1 over 2 squared, so it's 1/4. So it's going to be rather flat. And then here, 2 comma 2, so then we get positive 1 over 4. So flat, but in positive direction. So that's basically what we have done. Part B, find particular solution in this given condition. So what are we going to do? Same deal. So dy over y minus 1 is equal to dx over x squared. So when I integrate this one, I'll be getting ln of absolute value of y minus 1. On my right side, we get x to the negative 1, so it becomes negative 1 over x plus c. So now what I'm going to do is I'm going to erase both of them by e, so we get y minus 1 should be equal to e to the negative 1 over x plus c. But the thing is, you see this plus c and the exponent is the same thing as multiplication, so we get y minus 1 is equal to c times e to the negative 1 over x. Now when I add 1, then I get to realize that. Let me just continue, or let me just do that here. Y is equal to c times e to the negative 1 over x plus 1. But what's the condition? When x equals 2, y has to be equal to 0. So then we get, when x equals 2, so 0 equals c times e to the negative 1/2 power plus 1. Then what I end up getting is, I'll bring this one over, so I get negative 1 equals c times e to the negative 1/2. So that means c is equal to negative e to the positive 1/2 when I have to divide by that. So then what do we end up getting, guys? Our equation is y equals negative e to the 1/2 power times e to the negative 1 over x plus 1. Or if you want to simplify that further, we can write it as y equals negative e to the 1/2 minus 1 over x, all of them in the exponent, plus 1. Now, second, as a limit of negative e to the 1/2 minus 1 over x plus 1, as x approaches infinity, then what happened here, guys? That's part C, by the way. Then you get to realize that this component becomes 0 as x approaches infinity. So this becomes 0. So then what's left is negative e to the 1/2 power plus 1. That's your final answer. Alrighty. So with that one, I'm going to close up. I'll see you later.